Have you ever looked up at the vast, star-dusted night sky and felt a sense of immense depth? You see planets, stars, and galaxies stretching out in three glorious dimensions. There's up and down, left and right, and forward and back. It all seems so real, so solid, so 3D. But what if I told you that this grand, sprawling universe with all its cosmic nooks and crannies might be an illusion? Not a dream exactly, but something more like a projection. A fantastically detailed hologram whose fundamental blueprint is written on a distant two-dimensional surface. This is the core idea of the holographic principle, and it's honestly one of the most mind-bending concepts in modern physics. It sounds like a plot straight out of science fiction, doesn't it? The notion that our perceived reality, with its tangible objects and seemingly endless space, is just a complex light show. Yet this isn't some wild guess from the fringes of science. It's a serious proposal that emerged from the rigorous study of one of the universe's most mysterious objects, the black hole. Before we dive into the cosmic deep end, let's get our feet wet with a hologram you might already know. Think about that little shiny square on your credit card or driver's license. Our journey into the holographic universe begins, as so many strange physics tales do, with black holes. These are regions of space-time where gravity is so incredibly strong that nothing, not even light, can escape. For a long time, physicists had a tidy picture of them. They were simple objects, described by just three properties: their mass, their spin, and their electric charge. Then, in the 1970s, the brilliant Stephen Hawking came along and made the problem even worse. He showed that black holes aren't entirely black after all. The first major clue in solving the black hole information puzzle came from a physicist named Jacob Bekenstein. He was pondering the entropy of a black hole. This was a revolutionary idea. The solution to the black hole information paradox was a triumph, but it opened up an even bigger and honestly more profound question. Physicists Gerard T. Hooft and Leonard Susskind decided to take this idea to its logical extreme. This was the birth of the holographic principle. Their reasoning was quite clever and relied on a thought experiment. This is the holographic principle in a nutshell. The answer came from a field called string theory, which is one of the leading candidates for a theory of everything. In 1997, a physicist named Juan Maldacena made a stunning breakthrough. One of the most famous was the holometer experiment at Fermilab in the United States. The holometer was an incredibly sensitive instrument, essentially a pair of powerful laser interferometers, designed to detect this holographic noise. After years of meticulous data collection, the holometer experiment announced its results. It found no evidence of the holographic noise it was looking for. At this point, you might be thinking, this is all very interesting, but does it really matter? Does it change anything about our daily lives, whether the universe is a hologram or not? But on a deeper, more fundamental level, it matters immensely. The holographic principle represents a paradigm shift in our understanding of reality itself. While the holographic principle is a beautiful and compelling idea, it's important to remember that it is still a work in progress. It exists at the cutting edge of theoretical physics, a place filled with more questions than answers. The holographic principle remains one of the most exciting and mysterious frontiers in science. It ties together ideas from gravity, quantum mechanics, information theory, and cosmology into a single breathtaking picture.